Okay, for our second example, I'm just going to make up a power series, and here it is. Sigma n equals 1 to infinity, negative 1 to the n plus 1, x minus 5 to the n over n times 5 to the n. So this is artificial. We don't know what kind of graph it's related to, just for example. So you can pause the video if you need to write it down. So step one was, again, to apply a test. Because there's no factorial, I'm going to just stick with the root test because it's easier to use. Absolute value is going to get rid of the negative 1. So I'm going to get x minus 5 to the n all over n times 5 to the n. This is all to the 1 over nth power, has to be less than 1 by the root test to converge. Let me go ahead and distribute the n. So I get limit as n approaches infinity, absolute value of x minus 5 over n to the 1 over n times 5 has to be less than 1. Keep in mind this is n to the 1 over n. Keep in mind that that limit, again, was 1. So when all is said and done, what we're really left with when we take the limit is absolute value of x minus 5 all over 5 has to be less than 1. Step 2 is to solve for x. And how I'm going to do that is I'm going to actually first multiply by 5. So I'm going to get absolute value of x minus 5 is less than 5. Again, there's two cases for absolute value. You drop the absolute value, and then the other one, it's negative, and you switch inequality. So if I add 5 to both sides, it looks like my number line is going to go from 0 to 10. Okay, so we'll just set that up. There's 0, and there is 10. Step 3 is going to be to test the endpoint. So let's start with x equals 0. This one's going to get a little complicated, so we'll be very careful to work this out completely. So it's going to go n minus 1 to infinity, negative 1 to the n plus 1. Now, it used to be x minus 5, but it's going to be 0 minus 5. So now it's going to be negative 5 to the n all over n times 5 to the n. Okay, it is going to get very easy to assume that things cancel and you have an alternating harmonic, which is the mistake a lot of students will make. But let's take a careful look at this one more time. Okay, so if I pull out that to the n, this would just be a negative 1 to the n. Okay, so the series really reduces to sigma n equals 1 to infinity, negative 1 to the n plus 1, and then there's that negative 1 to the n all over n. It's going to make a huge difference if this alternates or not, so let's just be sure. If I combine the negative 1 base, it's going to be n plus 1 plus n, which is 2n plus 1 all over n. But notice this 2n plus 1 is always odd. Okay, so if I have negative 1 to an odd power, negative 1 to an odd power does not alternate. It's always negative 1. So what I actually have for a series here is sigma n equals 1 to infinity, negative 1 over n, which is not alternating. So this is actually divergent by p series. Okay, if you need to see that again, just rewind the podcast and you should be okay. So the moral of the story here is you need to be very careful as you simplify. So now let's plug in 10. So I get the negative 1 to the n plus 1. It was x minus 5, so now it's going to be 10 minus 5, which is 5 to the n. And then have n, 5 to the n. Okay, this one, there's no issues. You can just cancel those out. So then our sigma will alternate here. So this is going to be negative 1 to the n plus 1 over n, which we know is an alternating harmonic, but this specifically converges by alternating series. Okay, so at 10 it's going to converge, at 0 it's going to diverge. 10 converge, 0 diverge. So if you want to write that as an answer, the interval up here is going to be from 0 to 10, like that. Okay, one other thing I want to add is notice the center of this interval right here is going to be 5. Which should come as no surprise because if you look at the original series, there is a shift of 5 to the right. Okay, one of the things the book is going to ask is what is the radius of convergence? So the radius from the center to the endpoint is just going to be 5. Okay, and if you look at example 1, the radius, the center is 0, which we should expect because there's no shift anywhere in the x, right? And so the radius here from center to endpoint, the radius is just going to be 1.